Hello and welcome to this Lab 4 instructional video on calculating confidence intervals. The objectives today will be to calculate 95 and 99% confidence intervals for sample mean, recode a categorical variable into a useful dichotomous variable, and calculate 95 and 99% confidence intervals for a sample proportion. So we're going to start by making sure we have SPSS open and our GSS 2018 dataset loaded. Then we're going to move on to part 1, where we're going to calculate confidence intervals for a sample mean. So the first thing we're going to do is we're going to go up to Analyze. We're going to go to Descriptive Statistics. And we're going to go to Explore. And in this lab, we're going to be looking at hours relaxed. Once we've found the variable, we're going to move it to our dependent list. We're going to select Statistics. And we're going to make sure we have descriptive selected here for a mean of 95%. Looks good, we have descriptive selected, and we have a confidence interval for mean of 95%. We're going to hit continue and then OK. Alright, so the first thing you notice, it does provide some of those basic descriptive statistics here. We have the valid percent, valid n compared to the total. But as we go down here, we notice that we have the mean here for number of hours relaxed per day, the standard error, and then the 95% confidence interval. And so what this is saying is that if we were to infer from the sample to the population, we could say that with 95% confidence that the population parameter, population mean for number of hours relaxed per day is between 3.58 and 3.87 hours. And so that's what that means. Let's try this again, but we're going to use the confidence interval of 99%. So same process as before. We're going to go to Analyze, Descriptives, Explore. We have hours relaxed here, but we're going to go to Statistics here, and we're going to change this 95% to a 99%. We're going to hit OK. Alright, so here's our second one. You'll notice that the valid n and all that sort of basic information is the same. But let's take a look at what happens to our confidence intervals. So for our 99% confidence intervals, we have between 3.53 and 3.92 hours relaxed per day compared to our 95% confidence interval, which is 3.58 and 3.87. So our confidence interval got wider as our confidence level went up as we went from that 95 to 99%. Now let's try something else. Let's look at how males and females differ from each other. So again, we're going to go to Analyze, Descriptive Statistics, Explore. We have hours relaxed in our dependent list, but this time we're going to move sex into our factor list. We're going to go to Statistics, we're going to change this back to 95, hit Continue, and OK. Now what we've done is we can compare the number of hours men and women get to relax. And we can see here that at the 95% confidence interval, or confidence level, men relax between 3.76 and 4.18 hours per day, whereas women relax between 3.3 and 3.69 hours per day. Which means that we can be 95% confident that men relax more than women, because this upper bound for women at 3.69 is still lower than that lower bound for men. Let's try this again for the 99% confidence level. Again, you're going to go to Descriptive Statistics, Explore. I'm going to keep all this the same, but we're going to change this to 99. We're going to hit OK. Alright, so let's see how this changed. So we have between 3.69 and 4.25, and between 3.24 and 3.76. And what that means, because now our confidence interval for men and women overlap a little bit, you can see that the upper bound for women is higher than the lower bound for men. That means we cannot say with 99% confidence that men relax more than women. With 95% confidence we can, but not with 99% confidence. Now let's try using confidence intervals for a dichotomous variable or for proportions. So the first thing we're going to do is we're going to try to recode a variable and make what is called a dichotomous variable or a dummy variable, which basically means we're creating a variable that has only two categories. So the first thing we're going to do is we're going to look at our variable of interest. In this case, we're using AB moral. So we're going to go to Analyze, Reports, Codebook, and we're going to go to AB moral. Move that to our codebook variables. And what this will generate is a basic description of the variable. And it gives us the label, respondent has a moral opposition to abortion, right? And it gives us the values and categories. So 1 is morally opposed, so the respondent is morally opposed to abortion. 2, the respondent is not morally opposed. And 3 is it depends. And so what we'd like to do is to recode this into a dummy variable or into a dichotomous variable. So to do this, we're going to go to Transform. We're going to go to Recode into different variables right here. We're going to take AB moral and we're going to move that into our input area. We're going to name the output variable here DAB moral to stand for dummy or dichotomous version of AB moral. And we're going to label this as AB moral dummy variable. Next, we're going to go to Change here, and we're going to select old and new values. And this is what we're going to do with these old and new values. First, on this left side, we're going to put in the old value. For our purposes, we want to keep people who are opposed to abortion in one category. And so we're going to select 1, right? 1, if we looked back here, is people who are morally opposed. And we're going to select the new value as 1 as well. So these are people that are morally opposed to abortion, and we're going to keep them the same. We're going to put 1 here and 1 here, and click Add. Next, we're going to use 2 and 3 and combine them together. The people who are not morally opposed for whatever reason, or people who are, it depends, and we're going to lump them into one category because they're not people who just immediately said they're morally opposed. We're going to lump them into one category. And so we're going to say range 2 through 3. So that'll include both this category 2 for not morally opposed and 3, it depends. And the new value we're going to have for this is 0. And we're labeling it 0 so that we can use the mean that we generate from between 0 and 1. The number of people who have 0 and the number of people who have 1 will generate a mean from that. And that mean will be the proportion of people who are morally opposed to abortion. So let's go ahead and click Add. So now we have a new variable that we're going to generate where we're going to keep people who are morally opposed to abortion in one category and label them 1. And we're going to take the other two that groups, not morally opposed and it depends, and create a new category for them of people who are just not automatically morally opposed to abortion, and we're going to label them 0, and this will allow us to generate proportions for people, the proportion of people who are morally opposed to abortion. So let's go ahead and click Continue, and then OK. And so it doesn't automatically show up, but now we have a dummy variable. And if you look here at our list of variables, and we scroll down to the bottom, you will see we have a DAB moral. And then if we go to Analyze and get some descriptive statistics, and we'll do frequencies here. We have AB moral. We'll move over and we'll compare our two variables to make sure we did this correctly. So we've made our two frequency tables, and we can see that 1 here we want to be equal to morally opposed for our original variable, and we can see that the frequency is the same, percentage is the same, that looks good. And then 0 here should be equal to categories 2 and 3 here, so not morally opposed plus it depends. And as you can see, if we add these two together, it will be equal to 1,627. So we're good there as well. So it looks like we've successfully created this dummy variable. So now we're going to go back and we're going to use that explore feature. So again, going up to Analyze, Descriptive Statistics, Explore, and instead of hours relaxed, use our dummy variable instead. We can see that our mean for men is 0.269. That means 26.9% of men oppose abortion. And the mean here for women is 0.3045, which means 30.45% of women oppose abortion. And we can see we have our confidence intervals here. And it doesn't appear that we can say that men and women differ significantly because these categories overlap, right? The upper bound for women is higher than the lower bound for men, so we can't say that they differ. So that's the lab for today. You can check out the lab activity assignment here and complete those questions. If you have any issues, please let me know. Otherwise, thank you and have a good day.